Dirty Bird podcast contains foul language and is not appropriate for young fledglings. Listener discretion is advised. Our intro music is brought to you by Ricky Pistone, aka Dick Piston. And our outro music is brought to you by the Sidewalk Slammers. Check them out wherever you get your music.
Are you looking for a podcast today with ornithology and humor you crave? Well, I know of these guys and it's birds they like. It's Dirty Bird, yeah, they're just a couple guys who really like birds. It's Dirty Bird, yeah, they're pretty dirty, but they really like birds.
Hello, and welcome to Dirty Bird Podcast, a podcast that's serious about birds, but nothing else. I'm Dr. John, and in each episode I pick an individual bird species and tell you all you need to know about them, from their life history, to their conservation status, to their evolutionary history. I do all the research and reading of scientific articles so you don't have to, and I try to add my own dirty spin and dumb jokes to keep things interesting. I also record my episodes outside so you can enjoy the sound of nature while you learn. Most of the nature you're probably hearing right now is a bunch of flies and bees that are buzzing around, but I'm recording today from the Monongahela National Forest, actually right outside of the Bear Heaven entrance to Bowden Cave. True hardcore Dirty Bird podcast listeners might remember this. It's the cave I fled into when it started raining when I was recording my cuckoo episode. But I'm recording here because today I'm talking about the only cave living, true cave, deep in the cave living bird species, the oilbird. And as I look at the pretty gaping, glaring entrance to this cave, I'm totally going to post a picture of this on my Instagram. I can just imagine oil birds in it. I would actually be pretty freaked out if I heard oil birds inside of that cave. This episode was suggested by Skiatsi on Instagram. Thanks for suggesting this episode. Guys, if you want to hear about a specific bird, just contact me, dirtybirdpodcast at gmail.com, or on Instagram at dirtybirdpodcast. I'm happy to do listener-suggested birds. Before I begin, I just want to do two things. One, give a shout out to Chelsea, Dirty Bird super fan. Watch out, J Pogo. You got other super fans gunning for your status. And I also am excited. I wanted to introduce a new short segment that I want to start doing at the beginning of each episode that I'm going to call Birdwatch. This is just a short little brief talk about cool birding experiences or birds recently in the news in some way. I'm looking for audience participation here too, so feel free to send me a voice memo, email, or Instagram message telling me about some fun birding experience you had, or about just anything interesting bird related, and I'm happy to begin the show with it. I'll start us off. I want to talk about a cool birding experience I recently had when I was on the New River Gorge in West Virginia, camping out there with my wife. And I was sitting on the river, just kind of watching everything. We saw otters. It was super cool, some mergansers. I hear a pileated pretty far off. Hopefully the mic picked that up. But anyway, I saw these birds kind of swooping down and grabbing, bugs that were hovering above the water. And I totally thought they were, tree swallows or swifts. I see them do this all the time over rivers. And so I didn't really think too much of it. But when I finally pulled out the binoculars and got them in the binoculars, I could tell that they were cedar waxwings, which was crazy because I just did an episode on cedar waxwings. I talked about how they, do eat bugs some, but, mostly they're berry eaters. And like, I don't really think of them as really good bug specialists. Like, it takes a crazy amount of aerial acrobatics to be able to catch a little tiny bug that's hovering above the water. But they were doing it with finesse and looking like swifts when they did it. So it was really cool watching the cedar waxwings do that. I had no idea that they did that behavior. So that's our bird watch. And let's go ahead and launch in to talk about the oilbird. This is so cool. This was probably one of my favorite episodes to research because just the more I learned, the more fascinated I was, and the more I respected these birds. They're sort of like the Superman or the Kryptonians of the bird world. I feel like when I cover most bird species, they each have like their own little superpower. Like, vultures have that super smell, and peregrines have the super speed. Oilbirds, they're like Superman. Oh yeah, he's got super strength, but also he can fly, and he's got X-ray vision. As we'll see, oilbirds have all these little superpowers, like they won the evolutionary lottery in some ways. So listen to this episode, learn about their superpowers like their amazing night vision eyes, their echolocation abilities, and their super sniffer that can find any avocado. This was also a really interesting episode to research because while these fascinating birds have sparked a lot of scientific interest, they live in pretty remote rainforest locations and apparently don't do well in captivity. So there's still a lot of areas of research that are needed. There's still a lot of mystery surrounding their life history. So I was really able to scour pretty much all the literature out there about them. I'll start off with a description about them. So they're about a foot long. And like many of their nightjar relatives that we'll talk about, they're not fancy to look at. They have what's called cryptic plumage. They pretty much camouflage into the forest. They are a nocturnal species, and when you're only out at night, you don't really need any fancy colors, none of them's highfalutin yellows that those warblers have. They're mostly just a drab reddish brown color. They have some small white spots dispersed also throughout their plumage. They especially have some white spotting on the outer primary feathers of their wings and tail that have rows of larger white dots bordered with black. It's actually theorized that these dots that really do stand out when they're flying are for low light conditions so that they're able to see each other and see where the wing or tail of their neighbor is so that they don't crash into them. They have pretty large eyes, like a lot of nightjars. I mean, they're nocturnal, so they got to see. And as we'll talk about, they have a pretty hooked bill, more hooked than you would expect, and especially compared to lots of other nightjars that have very straight or short bills. And then we'll also talk about more in depth, but they have rectal bristles. They have these special feathers that kind of look like hairs or whiskers that surround their bill. And they're a little hard to describe. I think you'll just have to look up a picture. All nightjars kind of look a little weird. They look a little like smushed to me when I see them. So definitely look up a picture. Honestly, most of the pictures, I was like, where is the bird? Because they have such cryptic plumage that they just kind of blend in with the rocks that they're usually photographed on. So let's explain why they're called oilbirds. It's a very distinctive common name. So this name was given to them by Alexander von Humboldt. He's a super interesting historical figure. He was a German naturalist, traveled extensively in the Americas in the late 1700s and in the early 1800s. In fact, he made such an impression on America that his name can be found all over the U.S. There's parks, universities, towns, and even counties that are named after him. He's known as the father of ecology and was really way ahead of his time. When you read about his ideas and everything, he's like talking about man-made climate change, and he's like starting to hint at evolution. This is well before Charles Darwin. So look this guy up and read about him. He's super interesting. He's definitely up there on my top historical figures to go birding with. I don't know who else is on that list. I think Attila the Hun was super into like falconry. Maybe he would be Interesting to burn with. He would know all about birds of prey. Anyway, back to oilbirds. So when Alexander von Humboldt was in Venezuela, he visited the Guachero Cavern, a large limestone cave that is inhabited by oilbirds. He observed how the natives collected the birds, especially the nestlings, and rendered their bodies in order to make lamp oil. So, lamp oil, oil bird. He actually also coined the scientific name for these birds too, Steatornis carapensis. Steatornis is a combination of the Latin stia for fat and ornis for bird. Carapensis refers to the town of Carape, which was nearby to the Guachero Cavern. Guachero Cavern is actually named after a Spanish colloquial name for the oil birds. The origin of the name Guachero isn't super clear, though. It may come from the Spanish word guacho, meaning vagabond, or the native Quinchua word Huacha, meaning an orphaned or bastard child, or some combination of the two. And this refers to the anguished cries of the bird, which make it sound sad or lonely. Another colloquial name referring to its calls is Diablaton, meaning little devil in French, and it is also referring to its calls, more of the demonic sounding quality of them. We're in the middle of a drought here in West Virginia. It has barely rained. I'm actually kind of just outside the cave, kind of in the stream bed, which is empty. It's often full, but there's still a lot of, mountain springs. And so there is a little tiny trickling waterfall just a little bit up from me. And I've noticed other than alarm calls, like when I was walking in, I heard a lot of bird alarm calls. And when I was first yeah. And speak of it, that sounds like a pileated woodpecker alarm call. But yeah, I haven't really heard much song. I mean, we are, late into the summer, so breeding is pretty much done. Most of them are concentrating on either getting ready for the winter or getting ready for migration. I did see a little flock of yellow-rumped warblers when I was walking in. So, as I said earlier, oilbirds are only found in very specific environments, rainforests, and near caves. They're actually found only in the neotropics of South and Central America, ranging from Bolivia to Colombia, and Trinidad also. Within this range, though, they are confined to those very specific habitats of rainforests with fruiting trees, and having caves for them to nest in. Although, as we'll talk about, they can be found pretty far away from caves, but that's kind of like their home base is going to be in caves. They specifically need caves that have many ledges to perch and build their nests on. Oilbirds have really weak feet and are unable to cling to vertical surfaces the way birds like chimney swifts can, so they need some flat ledges within the cave. Also, these caves must be inside rainforests with many fruit trees, because as we'll talk about in just a second, they eat entirely fruit. So it's kind of a limited range that they're already in, only in South America, stretching just a little bit up into Central America. And then within that range, they require a pretty selective environment with the caves to breed in, and, the fruit trees for them to feed on. And even if all these requirements are satisfied, and you are within this bird's unique habitat, you're unlikely to see them because they're nocturnal. And even in the daytime, they are usually just roosting deep within the cave, and you're not really going to find them unless, you're heading in there, or they're high up in the canopy of the rainforest. And remember, they got that very cryptic plumage, so they're very difficult to see. So let's dive into the feeding section on these birds. I'm going to cover some amazing stuff here because I can't talk about, how they eat without talking about their incredible adaptations. So first off is that beak that I talked about. So their beak is hooked. It honestly looks like a hawk beak. Except, they're not doing any ripping or eating with this beak. Their entire feeding style is to just locate fruit and swallow it up whole. So I didn't really see what this hooked beak was actually for. My thought is maybe it's for like plucking fruit, off the stem. It helps with that. And the fact that they swallow fruit whole is just a super advantageous thing for the trees because they're spreading the seeds. As you know, birds shit a lot. And most birds have pretty short guts, so they basically just eat, absorb whatever they can, and then shit it out real quick so that they aren't too heavy to fly. Oilbirds actually have much slower gut transit times compared to other birds, about 6 hours. For reference, the pigeon gut transit time is 30 minutes, and there's birds that their transit time is as low as 4 minutes. This may allow them to absorb more nutrients, especially fats, from their fruit-rich diet, but it also allows seeds to be dispersed far away from where they were consumed. Oilbirds move an average of 60 kilometers or 37 miles each night, and so they can really spread some seeds around while they're foraging. During the non-breeding season, they won't necessarily return to the cave every night. They may spend several nights roaming the forest, spreading seed shit far and wide. These far-ranging feedings appear pretty purposeful, meaning oilbirds aren't just like randomly moving around the forest, like bumping into a fruit tree. Oh, there's one. Oh, I guess I'll eat it. When they do GPS tracking of these birds, they're moving in like straight lines at very purposeful flights. So they know exactly where the good fruit trees are. Further research is needed to determine whether they're using mental mapping to do these searches, or they're using olfactory cues. Well, we'll talk about their noses in a moment. Or there's shared knowledge among the colony that helps direct them towards food sources. Like one oilbird finds a good spot and comes back and somehow is able to communicate that to others or leads them to it. They don't only poop out seeds, because some of the fruit they eat have very, very large seeds. So what they'll do with those ones that are too large to pass through their gut is they'll just swallow them, and then their muscular stomach will strip off the pulp of the fruit, and then they'll regurgitate up the seed while the rest of the fruit goes its merry way along the rest of the digestive tract. And this allows them to still feed on fruits with particularly large seeds like avocados. In fact, I read a paper that theorized oilbirds are just as efficient, if not more so, than now extinct megafauna like giant ground sloths and mammoth for distributing large fruit seeds. This is another John tangent, but there's some really interesting, theories and research out there about North American vegetables and fruits that are like now kind of obsolete or went extinct when a lot of the megafauna went extinct. About like 10,000 years ago, like in the Americas, things like mammoth and giant ground sloths and, the other crazy large animals you see in like the Ice Age movies. That's my frame of reference. They were obviously eating a lot of stuff and, walking and helping to spread it around. There's stuff like pumpkins. Nothing really like eats and spreads around pumpkin seeds. Pumpkins aren't really, wild anymore. They were cultivated by Native Americans. And so it's thought that pumpkins kind of co-evolved with like mammoths, maybe like mammoths would eat them and help spread their seeds. And if it wasn't for Native Americans kind of like, oh, we like this, let's adopt it as a farm crop, then they probably would have gone extinct. There's a couple other ones like that too. Osage oranges also are another one. But yeah, so basically what some papers I read argued were these fruit trees, yeah, maybe the giant, extinct megafauna did help with spreading them, but they got oilbirds, so they didn't even worry when the megafauna went extinct because the oilbirds were probably, even better at spreading the seeds. And we'll touch back on this in the evolutionary section too. So their diet is mostly made up of various palm species. Palm fruit is pretty much the majority of their diet. But they also eat avocados along with some other rainforest fruit trees that I've never heard of, like Lycaria, Hediosmum, Nectandra, Ocotiae, Dacroides, and Tradonicae. I probably mispronounced a lot of those, but I think the only people that would recognize those species or recognize my mispronunciation would be botanists anyway. So those are just like the scientific names for various genuses of trees from which scientists have recovered, seeds from the droppings of the oil birds, and so know that, that's what they feed on. I really couldn't find much common names, but some of the common names you might recognize. Laurels, torchwood also is another one of those species. And also they eat a lot of fruits from plants that are called incense plants. There was some clouds, and now the sun's kind of come out. And I found, every time the sun pokes out, I think the birds just feel a little happy, and they can't even help it. They gotta sing, even if it's not breeding season. I found a really cool paper that compared the local knowledge of the indigenous Aguaruna people of Peru and our scientific knowledge of oilbirds. The Aguaruna know the oilbird as tayu. And they know the oilbirds well because they're some of the indigenous people that harvest the nestlings. The nestlings are important fat reserves to their diet, and fat is a very scarce food commodity in the Amazon. So this study found that the Aguaruna knowledge compared pretty on spot with scientific studies of oilbird diet. Likely because the Aguaruna, when they're harvesting the nestlings, they observe what seeds are contained in the oilbird droppings when they're in the cave raiding those nests. And really, they're amazing evolutionary adaptations. It all comes from 1, this fruit diet, and 2, from their nocturnal habits. So first off in their amazing adaptations is their flight style. So these birds, they're not that large. They're like a foot long, but they have very big wings and very big tails. So this leads to them having a low wing aspect ratio, and they have low wing loading. Woo! Both of my aerodynamic buzzwords. I've talked about these two things so much on the show, especially my vulture episodes. I think I talk about it in my Godwit episode. I'm not going to go into detail of it. Oh my gosh, I don't want to belabor the point. But basically, wing load refers to an animal's weight divided by its wing size. And, the lower this ratio is, the slower an animal can fly and still stay airborne. This makes sense. If its weight's low and its wings are big, it can stay airborne at low speeds. Oilbirds are pretty heavy, actually, for a bird of their size. They weigh around 400 grams. However, they have 3-foot wingspans, and this helps to off-balance their a little bit heavier weight. And they also have those large fan tails that basically add to their wingspan. Their tail almost acts like an extra wing. So then they have a low wing aspect ratio. So wing aspect ratio, this is the ratio of a wing's length compared to its width. Short, stubby wings are great for maneuvering, while long, thin wings are great for lift and long flights. Like our Godwit, in our Godwit episode, they make the longest migration of any bird. And we talked about how their wings are pretty long and thin. But oilbirds, they're on the short, stubby side. This allows them to weave in and out of tree branches and also navigate tight cave corridors. Also with their wings, so oilbirds, they have slotted wings, similar to vultures. Think about when you see a vulture, they kind of have like feathers that stick out at the end. They look almost like fingers on the end of their wings. The aerodynamics behind slotted wingtips are crazy. I go into a lot of detail about this on some of my episodes. I think my brown pelican, bald eagle, and vulture episode, I talk about this. It's some really crazy physics. It involves each wingtip creating its own individual vortex, and all kinds of other stuff. But for the purposes of this episode, just think of each wing finger. It acts like its own individual mini wing on the bird's larger wing, which helps create more lift and also to reduce drag. And these aerodynamics all come together to allow oilbirds to actually hover in place. This is really important because they have to hover to be able to pluck fruit, and also have to hover to kind of stop suddenly in the cave and be able to make tight turns, or to avoid their, friends that are flying in and out of the cave. As I mentioned earlier, they have these kind of whiskers around their beak. So these are called rectal bristles. They're modified feathers. A lot of other birds have these, especially nocturnal birds. And basically what they do is they supply tactile information to the bird. So they help them to feel their way around in the dark and to guide fruit into their mouth. So that's their flight and their feathers. Let's talk about echolocation. This is so cool. They're like the bats of the bird world. As I will talk, there are some other bird species that do use echolocation. But this is so cool because, they are using it to navigate within caves just like bats. Their ability to echolocate was first suggested by a guy named Griffin in 1958. He plugged up the ears of oilbirds and then released them in a dark room. After he watched them collide with the walls a bit, he unplugged their ears and then re-released them. Lo and behold, they no longer struck the walls. Their echolocation is a bit different from bats, though. While bats use high-frequency sounds to echolocate, oilbirds use short pulses of clicks, with the frequency actually being within the human hearing range. These lower frequency sounds result in lower vision acuity compared to those of bats. It's been proposed that oilbirds can't discern objects smaller than 20 centimeters with echolocation alone. This was done from experiments where they basically hung objects, with smaller and smaller diameters, and saw which ones oilbirds collided with and which ones they could avoid. I did see one study, though, that contends that report on the 20 centimeters. It reports that by using faster click pulses, oilbirds can discern objects as small as 3.2 centimeters. They also produce clicks at a much slower rate than bats. While bats can perform sonar pulses up to 200 a second, the maximum amount of clicks an oilbird can produce is just 10 a second. Still a lot, though. They will boost the signal volume of their echolocation depending on light condition. On moonless nights, they need to rely on it more, and so they will adjust their echolocation output up compared to nights with full moons. And this has been proven anecdotally and also in studies where they observe oilbirds. And if there's lots of moonlight out, then they won't really click very much to navigate. But if there isn't and it's pretty dark, then they will be clicking. So rather than them being, sole echolocation to navigate their way around, it's more of a combination of great night vision, which we'll talk about in a second, and echolocation that allows oilbirds to move around at night. They really only use the echolocation when they're inside caves. And this has been anecdotally shown by observations that if they're out feeding on fruit and a cloud goes over the moon, they will actually choose to just sit and perch in the trees and wait out the clouds rather than attempt to feed. There also was an experiment where a blindfold was placed over oilbird eyes, and they started clicking and using echolocation, but if that blindfold was removed, then they no longer clicked. The echolocation ability of oilbirds is really limited by their ears. They have only one bone in their middle ear, which is common to most, if not all, birds, while mammals, we have 3 bones in our middle ear. Our 3 bones in our middle ear act to amplify sound to the cochlea in the inner ear, which allows us to hear higher frequencies. With their only one bone in their middle ear, it's estimated that oilbirds can only hear frequencies up to 10 kilohertz. However, oilbirds emit many sounds at higher frequencies than that, meaning that they likely emit many sounds that they can't even hear. Also, the fact that oilbirds don't have external ears limits their ability to echolocate. Those large ears on bats help them to discern the time delay between a reflected sound reaching one ear or the other, thus helping them figure out where that object is in space. I'm glad oilbirds don't have ears. That sounds terrifying, picturing a bird with ears. But it is a big handicap for them. So that's their echolocation. Now let's talk about their amazing visual system. Like many other nocturnal species, oilbirds have relatively large eyes and pupil sizes compared to diurnal species. However, their eyes have several other characteristics that make them totally stand out from pretty much every other animal. Only maybe some deep-sea fishes rival them in their ability to see in the dark. The first comes with their rods and cones. Rods are the eye cells that detect light and movement, while cones see color and fine detail. Oilbirds have a rod-to-cone ratio of 123:1, which is 9 times that of owls. Also, compared to other bird species, their rods are sort of small and short. This allows them to be packed densely together, but it also allows for one other crazy anatomical feature. Oilbirds have 3 layers of rods in their eyes. It's like a light-detecting sandwich. Their retina is the McTriple burger of light-detecting cells. I'm not going to deep dive into the anatomy of how a retina works. I'd have to revisit some of my med school textbooks, to be honest, to really go into that. But these light-detecting rods, so they're separated by other cells that help to communicate visual information to the brain. While oilbirds have massive amounts of these rods, a large number of them will end up connecting to just one ganglion cell. Ganglion cells are basically the exit wire from the eye going to the brain. Since a lot of rods connect to one wire, if one of them sees light and it tells the ganglion, it'll communicate, yes, I saw light. I'm just not sure exactly where it came from. This means that while oilbirds are super sensitive to even small amounts of light, they trade this off for very low resolution power. Again, this probably isn't a problem for them because they are seeking out large, stationary fruit to eat. They don't really need good visual acuity. The highest concentrations of rod cells is found not in the center of oilbird retinas, like humans, our best vision is right in the center or macula. Rather, this is all on the sides for them. So they probably don't really see best by looking directly at an object. They see more in like a panoramic view, which this also makes sense too. They're kind of viewing the forest as a whole and trying to find where the fruit trees are at. One last comment on their rods. They have an astounding 1 million rods per millimeter squared, which is the highest recorded in any vertebrate. A cool fact I found that is if a human and an oilbird were looking at the same thing, oilbirds would be seeing it 4 times brighter. And with eyes this sensitive, oilbirds pretty much can't look at, direct lights. Like they would probably be blinded if they tried to, open their eyes in the middle of a sunny day. So that's why they are mostly roosting in caves during the day. They're only coming out at night. If they are out in the open during the day, they are in the canopy of the rainforest where it's, pretty much twilight all the time because of that dense vegetation. When you look at pictures of oilbirds, or if you are lucky enough to observe them in person, you will see that their eyes are glowing red. This, along with their harsh calls, really adds to their demonic reputation. So this glow, it is not from a tapetum lucidum, though. The tapetum lucidum, this is a special membrane that helps reflect light back to improve photosensitivity in nocturnal animals. It causes eye shine. You've probably seen this before in like a deer or another animal, or like you shine your light on your cat or something, and their eyes kind of shine at night. They reflect the light back. A lot of nocturnal animals have this. Some nocturnal birds have this, but oilbirds, they do not, which is surprising until you think about how they have those 3 layers of rods in their eyes. They don't need that tapetum lucidum because they pretty much capture any light that's available to them. That red shine is actually due to the reflection of their rods. They have so many rods that when you shine a light into their eyes, the rods themselves, a chemical in it, rhodopsin, it produces a red wavelength that reflects back a red wavelength of light. There's just so much of it in their eyes that's what you see. Finally, let's talk about their sense of smell. Anatomical studies of oilbirds show that the epithelium or outer skin layer of each nostril is thick and innervated by many nerves. All this wiring suggests that oilbirds have a refined sense of smell, which, outside of a few other species like vultures, kiwis, and petrels, is super rare in the bird world. They also have a tubular nasal conformation. It's similar to that of other species that I just mentioned, the petrels, kiwis, vultures. This tubular structure helps to carry scents into the nostrils. And this makes sense because most of the fruit trees that oilbirds feed on are very aromatic. In fact, one of the families of plants that they eat, like I said earlier, it's literally named the incense plants because so many essential oils are derived from them. And so oilbirds can smell them and find them. And there's likely a co-evolutionary relationship going on there. One adaptation oilbirds don't have, though, is silent flight. Many of their nocturnal relatives, like potus, nightjars, and owlet nightjars, have specialized feathers called velvet on their wings that help eliminate that flapping sound that birds make when they're flying. I talk about this more in my barred owl episode. Oilbirds, they don't have this, probably because their food can't hear them coming. There's no avocado with ears out there. I'm going to close this section talking about their bristles again. As we talked about with their echolocation and their vision, they don't have great resolution to fine detail. Their echolocation is pretty crude compared to bats. And then also their night vision, while it's super, super sensitive, it's not great visual acuity. Like they probably have a hard time telling exact details on objects. So that's where their bristles come in. So once they get close to something, their bristles help figure out the fine movements, whether it's a cave surface that they're trying to get around, a tree branch, or they're up close to a fruit and trying to direct it into their mouth. So let's talk about some of the sounds that these birds make. They are technically songbirds, but they don't sound like any songbirds you've ever heard before. Current Biology magazine described their vocalizations as a cacophony of ear-splitting demonic screams and snarls. I am instantly reminded of my episode on brown pelicans and turkey vultures with the way that they sounded like pterodactyls. Those birds, however, sounded that way because they don't have a syrinx. The syrinx is analogous to the human larynx, or a voice box that helps us talk, helps me record this podcast right now, but instead the syrinx helps certain species of birds sing. Despite their harsh calls, oilbirds do in fact have a syrinx. However, theirs is shaped much differently from many other birds. In humans and in most songbirds, the larynx/syrinx sits in the trachea, also known as the windpipe, which is basically that final tube that air passes through before you get to the mouth. The trachea splits into the left and right bronchi that go to their respective lungs. Oilbirds have two syrinxes that, instead of hanging out in the trachea, actually reside solely inside the bronchus. However, they aren't equal on each side. One side is longer than the other. This syrinx design has been theorized to allow them to produce individualized calls that can help mates and nestlings recognize each other in the darkness. Also, since they have a split syrinx, they have the ability to phonate through one side while the other remains closed. This allows for a lot of different variation. Like humans talking, oilbirds emit sounds with exhalation of air. Their echolocation clicks are formed by vibrating the folds in the syrinx caused by the contraction of the sternotrachealis muscles and terminated when another pair of muscles called the broncholateralis contract. In contrast, their harsh social calls are produced by relaxation of the sternotrachealis muscles. And I guess while I'm talking about them, being able to make individualized sounds to recognize each other. I'll also mention here, they apparently have a distinctive body odor, described as a musty smell. And this may further help them to recognize each other in the dark. They can smell each other. Bird BO. I'm sorry for all the bug sounds. I hope that doesn't trigger anybody, but there's the last gasp of some wildflowers out here, and I think that the bees and the hornets, they're just going crazy trying to get their last little fix before the real cold sets in. It's actually feeling a little cold where I'm sitting down in the stream bed, I think because the rocks have really held on to some of the cold nights we've been having. It's been dipping down into the 40s, getting down into the low 40s in early September here in West Virginia. So let's talk about their breeding. There's not a lot in detail known about their breeding. They're pretty hard to study because, they're a bird that breeds in absolute darkness along cave or cliff walls. They live and breed in colonies, though, that can contain from hundreds to thousands to, I think the upper limit I saw, the largest colony is around 15,000 birds. There's a lot of variation in where they place their nests in the caves. Some are within the twilight zone of the cave where there still is visible light. However, in places like Cueva del Guachero, which is that Guachero cave that I mentioned earlier that Humboldt visited, the nests there, they can get as deep as 819 meters into the cave. This is a zone of absolute darkness. They've done studies where people put film in there and leave it, and the film is just absolutely unchanged. There's absolutely no light penetrating through. They are monogamous. It's unclear whether this is for life or just for the breeding season. They have been observed doing courtship flights. These are at night. They will circle each other while emitting clicks and a harsh kurr sound. They breed semi-synchronously as a colony. So the colony, they all start breeding around the same time. It's not like literally they all lay eggs on the same day. It starts in April to May. It pairs with the rainy season. And this is to allow for, when they have their nestlings, there's the maximum amount of fruit available. Nests are built 30 to 60 feet off the ground on crevices and made up with a combination of saliva, regurgitated fruit pulp, and their own shit. The nest can get pretty big. I read up to a little over a foot in diameter. They lay 2 to 4 eggs. Their eggs are white but quickly become stained brown from the parents' droppings. The eggs are relatively small for the size of the bird, only about 1.5 inches long. They are more pointed at one end, which helps to keep them from rolling out of the nest. And both male and females appear to share incubation duties. It takes about a month for the eggs to hatch. They have a really long nesting period, 95 to 120 days. I mean, this is comparable to big birds, like ospreys or eagles. This super long nestling period is likely because they feed their young entirely fruit. This is really, really rare in the bird world. There's only a few species that do it. Even berry-loving cedar waxwings give their nestlings insects. It's crazy that they're able to survive on this. I think I've talked about in the show before that there's bird species where they've done experiments where they try to, feed them only fruit and kind of just see what happens. And they always die, of course. But they don't just survive on this, they thrive on it. The nestlings put on an incredible amount of fat during this time, becoming over 200 grams heavier than the adults during their peak bulk weight. And this is why, they were harvested by indigenous people and then, eventually harvested for lamp oil and called oilbirds. I read a really great paper. It was called, this is such a great title, Why Are Oilbirds Fat? And basically it tried to figure out this evolutionary quirk. The only other chicks to do this in the bird world are albatrosses and petrels, but the reason why they do it is because their parents leave for days at a time. I think sometimes even weeks, because, they go out over the ocean and they're waiting to find some food and forage, and then it takes them a while to come bring it back. So the chicks need these big fat reserves to survive. Oilbirds, though, their chicks get fed every single night, so that's not what's going on. One theory that this paper made was that oilbird nestlings fatten up in order to remain warm within the caves. The caves are relatively cool. And this also allows parents to spend less time brooding them and more time foraging. However, even after chicks develop insulating down at around day 20 and can thermoregulate pretty much for themselves, they continue to fatten up. So that's definitely not, the whole story of what's going on. So one reason why most birds can't rely on solely fruit is that it has a very low nitrogen content. Its protein content basically is very low compared to animal protein from insects or whatever else, animals the birds are eating. And nestlings, they need a lot of protein. They need a lot of nitrogen in order to grow. So when they're getting fed all this fruit, it results in an imbalance of nitrogen to calories, meaning that all that fat is more of a byproduct of their fruit-rich diet rather than a purposeful strategy. So basically, to make up for how little nitrogen and protein that fruit has in it, the parents feed the nestlings just a ton of it. And yes, the nestlings are able to get enough protein that way, but they're just ingesting a massive amount of fat and calories. To demonstrate just how much fruit nestlings need a night, that paper, the Why Oil Birds Are Fat, it calculated that a colony the size of Cueva del Guacharo, which has about 5,000 breeding pairs, it needs about 1,600 kilograms of fruit a night in order to feed the nestlings alone, not even counting what the adults need to eat. I feel like that's more than is going to be in an average supermarket. So to summarize, to overcome the relative low protein content of fruit, oilbird parents and nestlings just have to eat a lot of it. And in the growing nestling, this is so much that they inadvertently become morbidly obese. In the month leading up to their departure from the nest, they start cutting, though, and reduce their food consumption so that they drop down to the adult weight. They lose about 200 grams, and at this weight, they're able to still fly when they fully fledge. One final comment on breeding. One study I read examined the genetic diversity among an oilbird colony. It found very low genetic diversity in this colony, suggesting that birds born in the cave return to breed there, with very few vagrants coming into the colony. This suggests that oilbirds are pretty much fixed to their native nesting sites, with only the occasional gene flow occurring from wandering birds. This is similar to my puffin episode. I talked about how puffins, they have a lot of site fidelity. Where they're born is where they're going to stay and where they're going to breed, and it's only just the occasional wandering bird that helps found a new colony or helps spread some genes to new ones. And this is why if a colony is destroyed, it's just so devastating because, these birds are used to coming back and nesting there. So if, you might think, oh, it's just one cave, who cares? No, you might just be destroying it for all of those birds. They can't just up and leave and find a new place. And on that note, I'll go into kind of talking about their population and threats to them and everything like that. One really cool thing is because, they breed in these remote locations, these remote caves, there's still new colonies that are always being discovered. It was really cool reading papers about, new colony discovered in Ecuador or whatever. So, they live in these high altitudes in the Andes. I think I read up to 10,000 feet were some of the highest colonies that they found. It's rainforest. It's hard to get through. Caves, they're not as obvious as you would think. This Bear Heaven cave here, it took me 2 years, I think, to find, even though I had a map that talked about where it was. So these can be pretty hostile environments to humans where these colonies are located, and can be pretty accidental findings of them. And yeah, I had so much fun reading these papers. You guys should look them up if you're, in the scientific birding community and have access to some of them, because it's real life, the birding Indiana Jones. They're out there discovering new colonies of oilbirds that are literally in caves behind waterfalls. It's like a freaking RPG, always look behind the waterfall. There's going to be treasure. Yeah, it was awesome. Or they find just one, a local report reports, oh yeah, there was an oil bird that I saw flying over my house, and then they'll follow it back and follow it to the cavern and stuff. It's very cool. The bad thing is, though, some of these discoveries are paired with more and more rainforest being cleared and developed. Like, that's how they find these colonies, is because, big parts of the Amazon are being cleared and developed. And so, now all of a sudden, this cavern, which once was very inaccessible, now there's a road leading to it. While oilbirds are currently listed as a species of least concern, that could change very quickly if their unique habitat requirements are threatened. They require large tracts of forest and mature fruiting trees for feeding. Remember, they average 37 miles a night feeding on fruit and have been recorded on GPS traveling as much as 240 kilometers or 150 miles in their roamings to gather fruit. Local colonies are at high risk from overconsumption or just, human development destroying them. And there's some colonies that have shown signs of imminent collapse, with almost all of their nestlings being harvested for food. The current population of oilbirds is estimated at 100,000 to 500,000 individuals. And while they say, least concern, they're doing okay, I mean, that does not sound like a lot to me. One thing in their favor is that they really don't have any natural predators. Their cave environment removes them from most predation. Really the only thing that eats the nestlings is when they fall out of their nests, they'll get eaten by cave scavengers like cave crabs or rats. And I didn't read anything directly about this, but I'm sure adults do get preyed upon by hawks and falcons. But they're emerging at night from their caves. A lot of birds and bats, they'll emerge during dawn and dusk is when they're coming out, and hawks will literally wait for them and eat them. It seems like the oil birds, really it's more of they like the total darkness to come out into. And so that limits predators' abilities to see and hunt them. There's a bit more bird noise going on. I don't know if that's because, the sun's out in full strength right now, or maybe they've just gotten used to me sitting out here in this stream bed. I always, when I'm recording, I kind of turn around and look behind me a lot when I'm in the woods like this. And that is because I don't think I've ever told this story on air before, but that is because one time when I was doing this podcast out it was in the New River Gorge, actually. And I was actually sitting at a picnic table, and I heard a crunch behind me and turned around, and there was actually a juvenile black bear that was walking up on me. I don't know. He was a little guy. He's the size of a big golden retriever. So must have, just left his mom and everything. So I don't know what really he thought he was doing, whether he was just curious or I don't know. It's a big food item. I doubt it. But yeah, ever since then, I'm whenever I got these headphones on and a mic, I'm is there a bear coming up on me right now? Well, folks, let's wrap up the podcast talking about the evolution of oilbirds. So oilbirds are part of the order Caprimulgiformes, along with nightjars, potos, and frogmouse. I already discussed the evolutionary history of this order in my whippoorwill episode. Check that out if you want to know some more evolutionary information about this order as a whole. I also talk about the kind of wider history of this order and who it's related to in my swift episode, because the apodiforms, which swifts belong to, and also hummingbirds, I talk about them in my swift episode, so check that out. But kind of a crazy fact is, so there's the order Caprimulgiformes, there's the order Apodiformes. They are related, but I mean, that's millions and millions and millions of years of separation. So what's crazy is there are members of the Apodiformes the swiftlets that have the ability to echolocate also. And then, oilbirds and Capra mulgiformis, they can echolocate. So on the surface, you might think, oh, the common ancestor to Apodiformes and Capra mulgiformis, it could echolocate. And, that's why there's members within each of it that can echolocate, and then it just got lost in a lot of other species. But no, really, when you look at the phylogenetic analysis a bit more, it suggests that echolocation evolved independently 3 times within these groups of birds. Once for the basal ancestor of the oilbird, and then twice among the swiftlets. The oilbird, though, is really an evolutionary loner. It's not just the only member of its genus, but also the only member of its family, called Steatornithidae. This was not always the case, though. The family was likely much more diverse and also much more widespread than it is today. The evolutionary roots of Steatornithidae likely date to just before the Tertiary period, which began with the KT extinction event that marked the end of the dinosaurs. This is supported by something called an ED score, or evolutionary distinctiveness score, which basically estimates how genetically distinct a species is. The oilbird's ED score is actually the highest of any bird, suggesting it hasn't shared genes with any other taxa in 73 million years. During this time period, the Earth was much warmer and angiosperms and fruiting trees were just starting to take over the world from outcompeting ferns. Germany? I think that's a Carolina wren. This is demonstrated by the earliest known fossil of an oilbird dating from the early Eocene, about 50 million years ago. This primitive oilbird, termed Prephaca nivea, was discovered in the Green River Formation in Wyoming. We've talked about this formation a lot in the show. It has provided such a wealth of bird fossils, which are really rare in the fossil record. Alongside its fossil can also be found preserved seeds of angiosperm trees, some even with the same genus as laurel and palm trees that are preferred today in the diet of oilbirds. Also, its mandible was large and perfect for swallowing up fruits. So this shows that just like modern-day oilbirds, it had a fruit diet. But the sternum of Prephaca nivea suggests that it was not capable of hovering flight like modern-day oilbirds, suggesting it was not a cave specialist. It also shares many features with cuckoo rollers, which are a distant relative of the Capra order and the Apodiformes, so it kind of just shows the more primitive nature of this bird. There's also a tentative Steatornithidae fossil dating from the late Oligocene that was found in France about 23 million years ago. So these two fossils together, one from Wyoming, one from France, they suggest that the Steatornithidae were more widespread in the past, and also have been fruit specialists for tens of millions of years. The modern oilbird, limited to just South America, is likely a relic population of this much more widespread family in the past. Sounds like a mixed flock is starting to move through. Not sure if you can hear those titmice and chickadees. Go away, bug. It's been proposed that ancient oilbirds co-evolved with angiosperms and were instrumental in helping to spread them across the world and take over the previous existing flora. So it was kind of like a commensal relationship, The oilbirds were feeding on the fruiting trees, and by feeding on them, they're flying around, spreading their seeds, they're helping to make more fruit trees, allowing them to spread also, the oilbirds to spread also. So it was just kind of like a feedback loop, and they just kind of spread all around the world and did great. And then, the climate changed at some point, and the fruiting trees were not as plentiful, and the oilbirds eventually, regressed back. And also, the trees that had more of a smell to them, the incense trees, they were the ones that oilbirds were able to find easier. And so that kind of promoted evolution of more aromatic trees also. So if you like to use essential oils in your bath or whatever, you have oilbirds to thank. So just to summarize an evolutionary history of oilbirds, they come from the order Caprimulgiformes that contains other nocturnal birds like whippoorwill and nightjars. It's likely that their nocturnal habits are an ancestral trait dating back to their ED score of 73 million years ago. By 50 million years ago, they had made the transition from nocturnal insect-eating birds to nocturnal fruit-eating birds, as evidenced by that fossil from Wyoming. They may have been instrumental in spreading angiosperm trees across the world and likely were much more widespread, as hinted by the possible oilbird fossil from 23 million years ago in France. Finally, they became cave specialists and evolved echolocation, possibly due to their long nestling period that required them to have a very safe nestling site for their young to avoid predation. Well, I feel like the birds just know out in the forest when I'm done recording the podcast, because that's when they come out and decide to just sing and go crazy. But thanks y'all for joining me out here in the Monongahela National Forest by Bear Heaven Cave, which, I can imagine some oilbirds hanging out in this back in the day. Back, 15 million years ago, if this cave was here. Probably not. But thanks, y'all, and write in, tell me your bird watch. Send it in, and I'll play it on the show or read it, whatever. And as always, stay dirty, fellow birdies. Dirty Bird Podcast is brought to you by me, John, with my rotating panel of guests and co-hosts. Thanks for being on the show, everybody. The Dirty Bird theme song is by Wijpkema Stone. Check out his groovy and hilarious music videos on YouTube. The outro music you're listening to right now is a song New York Redneck by the Sidewalk Slammers. Check them out wherever you get your music. The Dirty Bird Podcast logo is by the very talented TJ Ranoski. And of course, a shout out to my beautiful wife, Lauren, who created my original logo. Check out the show notes for this episode for a full list of credits for any bird calls or sounds used in the episode. Thanks for listening.
At the track, drive into Brooklyn, ain't never coming back. Tim's on the ground in the concrete jungle. I might get into a little rumble.